Example 9.5. Current density, resistance, and electrical field for a current carrying wire. Calculate the current density, resistance, and electrical field of a 5 meters length of copper wire with a diameter of 2.53 millimeters. 12 gauge carrying a current of 10 mA. So the given 5 meters is the length of copper wire, and the 2.053 millimeter 12 gauge, it is the diameter of copper wire. So the strategy here, we can calculate the current density by first finding the cross-sectional area of the wire, which is A equals 3.31 millimeter square, and the definition of current density, G equals I or all over A. The resistance can be found using the length of the wire. Length is 5 meters, and the area and the dense resistivity of copper wire equals 1.68 times 10 to the power of negative 8 ohms times meter, where R equals resistivity times L all over A. The resistivity and the current density can be used to find the electrical field. So the solution here, first we calculate the current density. So 10 times 10 to the power of negative 3 A all over 3.31 times 10 to the power of negative 6 m squared. So the answer is 3.02 times 10 to the power of 3 A all over meter square. Next, the resistance of the wire. So 1.68 times 10 to the power of 8 negative 8 ohms times meter times 5 meters all over 3.31 times 10 to the power of negative 6 meter square. So the answer is 0.025 ohms. Finally, we find the electrical field. So 1.68 times 10 to the power of negative 8 ohms times meter times 3.02 times 10 to the power of 3 A all over meter square. So the answer is 5.07 times 10 to the power of negative 5 V over M. So the significance from this problem, so from these results, it is not surprising that copper is used for wires for carrying current because the resistance is quite small. We are going to note that the current density and the electrical field are independent of the length of the wire, but the voltage depends on the length.